Welcome to this channel. In today's lesson, we're going to be looking at the determination of net force. When you're calculating the net force, it is important that you work or you determine everything based on one plane. This will enable you to assign directions in the various directions that the forces act in. So what do I mean by the forces being assigned? Remember, force is a vector quantity, and because it is a vector quantity, you need to know in which direction it's going to be acting. And so that becomes important for you to be able to say, in a particular direction, you're going to assign it either a positive or a negative sign, so that you are able to then add or subtract as you determine the net force. However, when you are going to do that, the first thing that you should be able to do is, if you are given a scenario, you should be able to determine what the free body diagram is going to look like. So you must always think of these three aspects: that one, the forces need to be acting, or you're going to be doing your determination in a single plane, and that each of the directions are assigned, whether positive or negative, and that you must also have free body diagrams. Now, the free body diagram is something that's going to become very important, because it's going to enable you to do your calculation. And you also need to remember that your Fnet is found by saying Fnet is equal to MA. So this here would be the application of Newton's second law, and this here was also going to help you to perform all your calculations. So now let us start, and we'll give you a general example of what is going what you're going to be doing, or how you're going to apply these concepts. So the first one is to say, okay, fine, given a scenario in which you have an object that is acting on a horizontal plane, on a table on the ground, and let's say that object has got a mass m, and it has a force that acts to the right applied to it, and we shall call this our applied force. And in the opposite direction, let us say there is a force due to friction, FF, I'll just refer to it as FF, and then we are then going to say, okay, fine, what is the net force that acts on that object if the object moves with a constant velocity? The object moves with a constant velocity. If you're given that scenario, you are told that the object moves with a constant velocity. Before you start to do your calculation, the first thing that you should be able to do is to draw the free body diagram of all the forces that are acting on that object, and also in any given direction. So you would represent the object by means of a dot, and then you would then use a ruler to draw all the forces that are present. So that would be your F app, and you label it. And then in the opposite direction, you have that frictional force that is acting in that particular direction, right? And then you also would have the forces acting in the vertical direction, and the forces that are acting in the vertical direction would be the same size, because there is no net movement in the up or down direction. So this here is your F normal, which should be equal to your Fg, which is the weight of the object. It remains on the ground. So now, because this object is moving with a constant velocity, if it's moving with a constant velocity, you need to be able to tell what that means. If an object is moving with a constant velocity, it simply means that the object has got an acceleration equal to 0. A is going to be equal to 0. So now, what we need to be able to do is you need to first assign directions. If we've got a direction moving to the right, and then you've also got forces acting to the left as your FF is, you then assign the direction. So in this case, if you can choose, if I choose that the forces acting to the right, if I choose to say, okay, they're going to be positive, and then the forces that are acting to the left, I'm going to call them negative. If I now have to calculate the F net, I'm going to sum up or add up all the forces in this particular plane, in this case in the horizontal plane, and then that should be equal to my F net, which is going to be equal to my MA. So my F net in this case is going to be my F app plus my FF, and this is going to give me my mass times the acceleration. I write that formula. I remember the F net is the sum of all the forces that are acting. So I would actually write it this way before I start bringing in the directions. So what that simply then means, I said my forces to the right are going to be positive, plus my force to the left, which is going to be a negative force. F is going to be negative. So plus minus FF is going to give me my mass times the acceleration. So whatever the value of the mass is, multiplied by the acceleration. And in this case, because it's moving with a constant velocity, the acceleration is going to be equal to 0. So multiplied by 0. I then substitute or do the necessary calculation. So my F app is equal to my FF minus my FF is going to be equal to 0. So in this particular case, what I'm then going to be left with when I do my calculation, I'm going to have my F app being equal to F app is going to be equal to my FF. So in this case, when the acceleration is equal to 0, it means that the applied force is going to be equal to the frictional force, and hence there will be no acceleration. So if we didn't know and we needed to draw that, so the one that would mean that the frictional force, its representation would also need to be as big or as long as what you used to draw the F app. All right, so that is how you would calculate the F net for a body that's moving along the horizontal plane without any acceleration. Right, so this is on the horizontal plane. Now, if you were to calculate what happens in the vertical plane, remember what we said, this object is moving along the horizontal plane. So there is no movement in the vertical plane. So what that simply means is that the FF, the FG plus FN are going to be equal to 0. So on the vertical plane, the Fn, which is the normal force, plus your Fg, which is acting in the opposite direction, so plus minus Fg is going to be equal to m times 0 acceleration, because there's no acceleration in that plane. So it's also going to be equal to 0. That would mean that my Fn is going to be equal to my Fg. In other words, there is no movement in the horizontal plane. So my Fn is equal to Fg, and that is what is going to be the net force along the vertical plane. Remember, important to consider the following. One, you need to know that you work in a single plane at a time. You must assign directions, give the one a positive direction and the other a negative direction. And And secondly, or thirdly, you need to make sure that you draw or you represent the free body diagram of the scenario, and then you use that to help you determine your outcomes. And then you must also have the F net is equal to ma. Always consider, is there an acceleration or is there no acceleration? Thank you for watching. Please subscribe and like the video and send us any comments if you have any. Thank you. Until the next one.